In this chapter, we're going to look and discuss more on triangles, the properties of triangles. Now let's start with the parts of a triangle. We'll have a triangle that looks like this and with a small box like this. This denotes that the triangle is a right angled triangle, and that means that this angle here is 90 degrees. Okay, so we'll now have 90 degrees on this side. And don't forget our rule of triangles that says that the sum of angles in a triangle, of all the angles in the triangle, will always give you 180 degrees. So that means this angle plus this angle plus 90 will give you 180. Or we can say that this angle plus this angle will give you 90 degrees. Okay. Now, what are the sides of a triangle? The triangle has three sides. This side, the longest side of the triangle, is called the hypotenuse. Hypotenuse of the triangle. What does the hypotenuse mean? How do you know which part is the hypotenuse? The hypotenuse is always the longest side, or the side facing the 90 degrees. So this is the right angle here, and the side facing it is directly this, and this is called the hypotenuse. Okay, then we have other two sides. One is called the opposite, and another side called the adjacent. Now, assuming we are focusing on this angle, the opposite is the side directly looking at the angle we are talking about, and this is the opposite. Then the side adjoining the angle we are talking about is called the adjacent. So assuming we're talking about this angle, here now becomes the opposite, and this other side now becomes the adjacent. Okay, so the opposite and adjacent change depending on the angle we're talking about, but the hypotenuse is always the same. It's the side that faces the right angle. Okay, having discussed this, we're now going to discuss something, a very important rule known as the Pythagoras rule. And what does the Pythagoras rule mean? Pythagoras rule states that if you have a right angle triangle, in a right angle triangle, that the opposite square plus the adjacent square always give us hypotenuse square. Okay, so let's call here x, here y, and here z. Pythagoras rule now states that x squared plus y squared will give us z squared. Or can say that z equals the square root of x squared plus y squared. That's Pythagoras rule, and it's a very important rule whenever we're trying to find the sides of a triangle. Now let's look at examples to explain Pythagoras rule. Let's say we have a right angle triangle. This side is 3 cm and this other side 4 cm. It states to find here x, this side x squared using Pythagoras rule now be equal to 3 squared plus 4 squared. Therefore x squared equals 9 plus 16. X equals 25. Sorry, x squared equals 25. Then therefore x will be square root of 25. X then will be equal to 5. Okay, so that's an application of Pythagoras rule. Let's look at another example. Now this example goes this way. We have a triangle like this. A right angle triangle here is 13 cm. This other side 5 cm. We're told to find this side x. So Pythagoras rule now states that 5 squared plus x squared will give us 13 squared. Making x the subject of formula gives us that x squared equals 13 squared minus 5 squared. X squared will now be equal to 13 squared will give us 169, then minus 25. X squared will now give us 144. 144. Therefore, x will give us square root of 144. And what is square root of 144? 12. Therefore, this side equals 12 cm. Okay. Now let's look at other examples of Pythagoras theorem in triangles that are combined. You could have a triangle that looks like this. Then this other side, you have another triangle this way. And we're told that this is a right angle triangle, and this other side is also right angled. Okay, so if we are given something like this and we don't know the sides, or maybe we know one of these, and we're given here, let's say here AB. So with this AB, you can find C. Then with CX, you can now use CX to derive this side, which is unknown. So that's the principle of combination of triangles. Now let's look at one example. The example goes this way. It's a very long triangle. Okay. Then we'll have a line dividing this into two. This other side is 8 cm, and here is 12 cm. We don't know the value of here, but this side is 17 cm, and here is y cm. So we're told to find y and x. So how do we find y? This is right angle triangle. So to find y, using Pythagoras theorem, we have that y squared plus 8 squared equals 17 squared. Therefore, y squared, making it subject of formula, gives us 17 squared minus 8 squared. So y will be equal to, what is 17 squared? Will give us 289. Then minus 8 squared is 64. And when we subtract, we'll have it that y squared equals 5215. Therefore, y equals square root of 215, which is 15. So, therefore, y equals 15. Now that we have y as 15, we can now easily find x, because y here is 15 and the total length of this new triangle is 20. So our new triangle, we have this base to be 20 cm, that's 8 plus 12, and this as 15. So let me draw it out this way. I have 20 and 15, and we're told to find x. So x is the hypotenuse. We have x squared equals 15 squared plus 20 squared. Therefore, x squared equals 15 squared is 225, and 20 squared is 400. Therefore, x squared will now give us 625, and x will give us square root of 625, which is 25. So x equals 25 cm. Here is 25 cm. Okay. So now let's take another example, the last example on this chapter, and that is from a rectangle that is sliced diagonally. Okay, so I have here to be Q. This is 4, 3, and here is 3, 4. Now I'm not going to solve this. Whenever you see a triangle, right angle triangle with two sides as 3, 4, automatically you know that here is 5. 3 squared plus 4 squared equals 9 plus 16, which is 25, and square root of 25 will give us 5. It's a general number, don't ever forget it. 3, 4 is 5. So looking at this, 3, 4 gives us 5 here. So 5 is the final answer. We're going to solve it. Okay, so now I want you to click on take start quiz and answer all the questions.